Okay, hopefully day 2 goes better without having to reboot my computer like I did yesterday. And it is 9 seconds until they show us the problem. So let us take a look. On the way to your gravity sister in the room, your ship's computer beeps angrily about a 12:02 program alarm. I'm not going to worry about what that is. On the radio, an elf's already explaining how to handle the situation. That's perfectly normal. The ship's computer bursts into flames. Notify the elves that the computer's magic smoke seems to have escaped. The computer ran int code programs like the gravity assist program it was working on. Surely there are enough spare parts up there to build a new int code computer. The int code program is a list of integers separated by commas. Turn 1, start by looking at the first integer. Here you'll find an opcode, either 1, 2, or 99. The opcode indicates what to do. For example, 99 means that the program is finished and should immediately halt. Encountering an unknown opcode means something went wrong. Opcode 1 adds together numbers read from two positions, stores the result in the third position. The three integers immediately after the opcode tell you these three positions. The first two indicate the positions from which you should read the input values. Third indicates the position at which the output should be stored. For example, if it encounters 1, 10, 20, 30, you should read the values at positions 10 and 20, add those values, overwrite the value at position 30 with their sum. Code 2 looks like 1, except it multiplies the inputs instead of adding them. Again, the three integers after the opcode indicate inputs and out where they are, not their values. Once you're done processing an opcode, move to the next one by stepping forward 4 positions. For example, suppose you have the following program. For the purpose of the illustration, here it is split into multiple lines. The first 4 integers are positions 0, 1, 2, and 3. Together they represent the first opcode 1 addition. The positions 2 inputs 9 and 10, and the position of the output 3. To handle this opcode, you need the values at the input positions. Position 9 contains 30, position 10 contains 40. Add these numbers together, get 70, and store this value at the output position. Here the output position 3 is at position 3, so it overwrites itself. Afterwards, it looks like this. Step forward 4 positions to reach the next opcode 2. So opcode works just like the previous, but it multiplies instead of adding. The inputs are at positions 3 and 11. These positions need 70 and 50. Find these 3500. Position 0, semi forward, arrives at opcode 9. First step is to restore the gravity assist program to the 1202, blah, blah, blah. Do this before running the program. Replace position 1 with value 12. Place position 2 at. Okay, so this is one of these things that's pretty confusing, but we'll go with it. So say from typing import list, and then program is a list of ints, and then we want to be able to run a program. So def run a program, and it is going to destroy the program as it goes. So it'll be none. And let's say position equals 0, and opcode equals none. Actually, let's just do this. While program pause is not equal to 99, and we should use an enum, but I'm not going to use an enum because I'm lazy. That's halt. If program pause equals, and then the two possible opcodes are 1 and 2. So 1 is addition, 2 is multiplication. Elif program pause equals 2. Else raise runtime error, invalid opcode, program pause. Okay, so if it's 1, I want to read from two positions. So what I want to do is program pos plus 3 equals program pos plus 1 plus program pos plus 2. And then here I want to multiply these guys. And I think I've done this wrong already. So let's take a look again. So here's what I want to do. What I want to do is I want to say opcode loc1, loc2 equals program pos plus 1, program pos plus 2. And so if the opcode is 1, and let's go back and read these instructions once more. The three integers tell you these three positions. The first two indicate the positions. Okay, so that tells me that program and let me just, so I need to actually get those. So I don't want to do program pos plus 3. I want to do program loc3 equals program loc is short for location plus program loc2. And otherwise, if opcode equals 2, I want to multiply these. Otherwise, I raise runtime error. And then move to the next one by stepping forward 4 positions. And then I want to do pos plus equals 4. And so let me just do this. Okay, so prog1 equals this. Never use semicolons in Python, but in this case we'll do it because I want to fit these all in one line. Prog2 equals this, run prog2, assert prog2 equals this, prog3 is this guy, run prog3, assert prog3 equals that, and then prog4 equals this guy, run prog4, assert prog4, and part of me thinks I should have done this in like an immutable way so it spits so it doesn't modify the program in place, but you know, let's see where this goes wrong. Invalid syntax, because I put the comment before this thing. Let's try it again, and those all work. So that's good. Once you have a working computer, the first step is to restore the Gravity Assist program. To do this, before running the program, replace position 1 with the value 12 and replace position 2 with the value 2. What value is left at, so let me do that. Def alarm program. And so what I said program 1 is 12 and program 2 is 2. Program 1 equals 12. Program 2 equals 2. Run program. Return program 0. And so let's see if it gives us an actual test case for this one. It does not. So anyway, we have to get our input. So let's look at our input. And here I will just hard code this because it's short. And let's say actual program equals this. And here I'm going to actually be non-destructive for once. So I'll make a copy of it and then I can do that. And then print alarm program. So let's do this, and it gives me a number, and let's plug it in and see what happens, and see what we did wrong. Okay, that didn't copy, so okay, I should have done Control-Shift-C probably, and that's the right answer. Okay, good. Continue to part 2. Good, the new computer seems to be working correctly. Keep it nearby during this mission. You'll probably use it again. Real Inco computers support many more features than your new one, but we'll let you know what they are as you need them. However, your current priority should be to complete your gravity assist around the moon. For this mission to succeed, we should settle on... I never look at the live chat. Okay, well, no one's chatting, so it doesn't matter. Terminology. Encode programs are given a list of integers. The value uses the integer state for the computer's memory. Your encode program, make sure to start by initializing memory of the program's value. Sufficient memory is called an address, transferring the first value to address 0. Opcodes of any instruction. Values in use are called parameters. For example, parameters, instruction 99 contains only an opcode, has no parameters. The address is called the instruction pointer, starts at 0. Instruction pointer increases by the number of values in the instruction until you add more instructions to the computer. This is always 4. If you add a multiply instruction, the whole instruction would do this. Terminal is ready to proceed. To complete the gravity assist, you need to determine what pair of inputs produces the output 19690720. The input should still be provided to the programmer by passing the values at addresses 1 and 2 just like before. In this program, the value placed in address 1 is called the noun. Value placed in address 2 is called the verb. Each of the two input values is between 0 and 99 inclusive. Once the program is halted, its output is able to address 0, also like before. Each time you try first set blah, 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 your puzzle input. In other words, don't use memory, find the output, noun, verb. What is 100? Okay, so we want to do this. So now this is why I've done this enough years that I was thinking ahead that I don't want to destroy the program. And so I'm going to change this a little bit. Noun int equals 12, verb int equals 2. I think that was their terminology. Noun, yeah. Okay, and so now it's parameterizable. And I can do this. So now what I want to do is I want to say each of the two inputs are between 0 and 99 inclusive. Okay, so I can just run those and say, you know, for noun in range 100, for verb in range 100, and let me just say target equals this. Let's say output equals alarm noun verb. If output equals target, print noun verb, and then break. Okay, so this is just saying, and just make sure, actually I want 100 times noun times verb, so let me just print that as well. Noun verb, 100 times noun times verb. And so it was saying, basically, each symbol values between 0 and 99, so we're just going to run each of those. And then once the program is halted, so just like before, each time make sure you first reset the computer's memory to the program. Don't reuse memory, which we've taken care of because we sliced it like that. 19690720. What is 100 times noun times verb? Okay, so so I think I'm doing this correctly. So let's whoops. So I forgot to feed it that thing. And then 5485, and that will get me 459,000. So wait, but it's 100 times noun plus verb. Okay, well, good thing I read that carefully. Let's try that again. And so it's 5485. 100 times noun plus verb. Submit. That's the right answer. 1 gold star, closer to rescuing Santa. And that got me my 2 stars for today. So that one was pretty pretty seamless. So I think that's good. So thanks for watching. I will do this again tomorrow. I have to do some traveling next week, so I won't be on schedule for every single day, but for the next couple of days I will, and that went well. So thanks for watching. I'll see you